Teradata is basically an RDBMS which will actually satisfy all the database rules. So database rules in the sense, the basic rules of relationship between data in the form of rows and tables. So that is called RDBMS system, right? The relationship between two tables might be existing, and why only Teradata for data warehousing? Okay. So in today's world, there are two different kind of systems, like OLTP systems and OLAP systems. And OLTP is basically on day-to-day transaction processing, right? Day-to-day activities, like in a mainframes, if you take Oracle, these are like most of the bankings or ICS, any bank they take, right? They use mainframes as most of the day-to-day transaction activities. And that is a OLTP system that actually Oracle database they use, or DB2, mainframes is DB2, right? So they use some different databases on a day-to-day transaction. So that is basically OLTP system. OLTP is very fast and accurate at any point of time. That is mostly very dynamic environment. So what is OLAP? OLAP is online analytical processing. So what is analytical processing here? Is basically, for example, when you wanted to do some kind of analysis, we should need some data, right? So this data will be stored in the form of tables by using OLAP methodologies, right? So for example, I'm the CEO of a company like Walmart. So before ordering the new products into my inventory, what should I do? I should check at least what is the current inventory. For example, if let's say I wanted to order Nikon cameras. In my current inventory, I don't know how much stock is there, how many pieces were sold and how many yet to be sold, or what is the customer satisfaction. All these details, the analytical data, I don't have it in handy. So in that case, what I do, I will go back to my data warehouse and check in the reporting system whether I have all the required information, right? So those kind of analysis will be done by your OLAP systems. So that analysis is typically required for us to do some decision making process. For example, like this: product ID, product name, and percentage of sales, percentage of profit, okay, for per year, and percentage of sales per piece, something like this. This is kind of some analytical data. Let's say the product ID is 1, 2, 3, 4, product name is Nikon camera, percentage sales is 45%, profit is 34.5%, percentage of sales for is 2.5%. Let's say some numbers. So by seeing these numbers and customer satisfaction and all the difference, and customer satisfaction percentage here, percentage of satisfied customers, let us say only 50%. Okay. Before ordering some new products into the market, I will see this kind of data into my OLAP systems, and I can think like, okay, so this is the data that I have in my current data warehouse. So I have only 50% customer satisfaction for my product. So what's wrong? What's went wrong with this? And the percentage of sales are declining from this year to the last year. So I wanted to do something, or prevent this order again to put into my warehouse, so that I can go for some other product. If I'm comparing two camera products, let's say Canon is doing better than Nikon as per the data that you have in your data warehouse. So instead of ordering Nikon cameras more, we'll be ordering Canon into the inventory, right? That is a simple example I'm giving you to take a strategic decision, right? That is called strategic decision. So who will make your strategic decision? This will be done by your business, right? Because obviously they will be running the show. The business will come to picture whenever they see some kind of this data based on the OLAP data. They will take the OLAP is nothing but here the data warehouse analysis data, right? So they will take some decision whether to order some new products, or go with the existing product, or exact decision can be taken based on this data availability. So that is called data warehouse, right? In a simple way, what I'm telling you to say is a purpose of data warehouse. Any questions so far? You clear?
Yes, Raj.
Okay, so this is about a basic introduction of OLAP. Now, where is Teradata fits into OLAP model? So OLAP have huge data in the sense, because it's a data warehouse, you will have history information, right? History in the sense you might have a lot of data into the system from last 10 years or 5 years data into the system. So obviously the system will be huge, and whenever you run the queries, the performance will matter. For example, you're writing a select query with so many other multiple join conditions, like you want so much data based on some different fields, right? So obviously we'll join multiple tables. So in that case, what happens if you use the traditional database like Oracle or SQL Server, they cannot actually withstand that much data. So Teradata actually came into picture this time. So to have huge volume loads, Teradata can actually select the data within fraction of seconds, even in billions of rows, because the architecture is designed in such a way that is purely for analytical data purposing. Okay, analytical data purpose is Teradata is designed, and the performance will be very high with respect to huge data. Performance is very high for Teradata. Okay, so for example, if you take 1 billion records, 1 million records, and if you take any other database, if you write a select query, the other database definitely will take more time than Teradata. Why so? Because the architecture is defined in Teradata in such a way that the parallel processing is enabled. So let's talk about Teradata architecture. What is parallel processing and all. So let me just go to the architecture point of view. So here this is the architecture of Teradata, right? So here let's say that any database have the parsing engine. That is common, right? So the parsing engine will take entire your query, and it will just execute the query. It will check for the syntax of the query and execute the query, give the results back to the user answer response. That is what the parsing engine does in real time, right? And why it is parallel processing? Because in Teradata, the main important component called AMP, that is Access Module Processing Unit, will be working in parallel to distribute the data operation. For example, you have a table of employee table, let's say 8 records, and we have 4 AMPs, and each AMP will take 2 records uniquely and store it. And whenever you write select star from table name a query, what happens? All your AMPs will give the data parallelly to the parsing engine. Like each AMP will work parallelly. They do not share anything between the resources. All AMPs will work in parallelly and send the data back to the parsing engine. Here it's a binary is just a communication mechanism. It is not doing anything with respect to the functionality. It is just a communication mechanism between your parsing engine and the AMP. Now, whenever you write some query, the AMP will check the corresponding the data stuff, and it will actually go for the parsing engine, the set of response back to the user. Okay, so that is what the parallel processing concept in Teradata. So instead of irrespective of storing into a single or centralized phase of data, they wanted to decentralize based on the number of AMPs. So the number of AMPs will work in parallel whenever you raise a request or you select a submit a query. So based on your index mechanism and all, we'll be talking about that later, what is indexing and all, and hashing algorithm in Teradata architecture. So based on that hashing value per given row, it will check in the corresponding AMP. For example, you're writing a query condition like select star from employee, where employee ID is equal to 1234. That employee ID 1234 value will be stored in one of the AMPs, and with respect to that hashing value based on the primary index that we define on the table, the corresponding row will be picked from the different AMPs. So it will be like a unique AMP operation when you use the primary index. So based on the hash value, it will go to the corresponding AMP and will get the data, but it won't search the entire table for that. It knows that where the data resides based on the primary index. Therefore, the value will be going back to the user response within a fraction of time. So that is the biggest advantage of Teradata in terms of performance compared to other databases. This parallel processing is one of the very important feature of Teradata, like hardcore process of Teradata, that actually gives a very much performance boost when you're writing the queries. And when you talk about parsing engine in detail, right? So parsing engine will basically does all these things. It will control your session, and parsing is nothing but it will check for syntaxes and all the things for your query level, and optimizing the plan. Optimizing in the sense based on the primary index that you define on the table. The Teradata will tell you, okay, there is a primary index already defined on this table, so why can't we use the primary index? So when you write the where condition, it will see that whether the condition is actually satisfying your table definition, and the where condition is actually being used on the primary index. So based on these conditions, the parsing engine will give you the explain plan. You might have known the explain plan, right? Similarly, parsing engine will give you the explain plan saying that, okay, this is the best way of doing the query. So that is what optimizer does. And finally, dispatcher. Dispatcher is basically once the plan is ready, the dispatcher will send the request to the corresponding AMS through the binary mechanism, right? So all the session control, parser, optimizer, dispatcher, all these four components will be part of parsing engine. So you might know that parsing engine is part of any other database, right? It is basically whenever you write some query, for example, let me just show you. This is a Teradata database that we have. Let me just start from a table name called td_dev is my database. Dot students is the database table. Students is there. So if I write the query, it is showing some data, right? So if I just remove the student yes symbol, it will say that object td_dev student doesn't exist. So this message comes from where? The parsing engine will tell you, okay, whether the table exists or not. So based on that, then only the data will be responded back to the user, right? So everything is whatever query that we are executing here, based on the query, whatever you are writing here, everything will be done by your parsing engine within fraction of second. We don't know what is actually happening to get this data, right? So the parsing engine will actually do all kind of stuff to get the required data. For example, if I do the explain plan, like for this query, right? It will just show you what are the steps that parsing engine has actually taken care. First of all, it will log the table for the data read access, and then it will check for TD students read table, and we do an all-amp retrieval. Here all-amp retrieval is nothing but, as per the parsing engine concerned, it will check for all the tables, because it has select star from table name is like entire data set, right? So it will check all the amps for the data. That is what it is saying. We do an all-amp retrieval step from student data table by way of all row scan with no residual condition. That means we completely searching the table with all the row scanning without any condition. That is what it is saying. So this is the steps taken by the parsing engine. Okay. So whenever you're trying to see the explain plan, it will tell you what are the steps that is actually taken, how much confidence and how much time it will take to execute the query, and all the things it will be tell you approximately based on the inputs that actually Teradata has at that point of time, right? So whenever you come to performance tuning and all the stuff, the parsing engine will play a crucial role while determining the query performance, right? You might use some different join conditions and poor join conditions, not primary index defined or not statistics defined properly. There are a lot of scenarios where the parsing engine will tell you, okay, this is the reason that actually this taking is long time, this query is running not good. So this is the recommendation that we have from parsing engine. All the suggestions comes from your parsing engine, right? So don't worry about this queries and explain plan. This is for the architecture purpose. I'm just giving you a brief about how the parsing engine will work, okay? So to get a better understanding on the real-time scenarios. Because parsing engine, if I tell directly theoretically, you don't understand anything. That is why I'm just showing a query with the example. So any questions here? You clear on this parsing engine part?
Raj, this is Ramkrishna. I have a question. Like, how important How important it is knowing the architecture of Teradata with ETL developer. I mean, in the role of
To
ETL
be
developer.
frank, you don't need to know the architecture of Teradata. You should be able to execute the queries and the BTEX script, that is fine. So this is only for our
Okay.
understanding how Teradata works, okay? So nobody
Okay.
will ask you about architecture in the real-time environment. Even the data architect doesn't know complete architecture of Teradata. So I mean, to be frank, this is only for our understanding how the AMS and all will work. But if you understand the architecture well, you will be able to, understand well about the system. But that is actually not very much what you say, con compulsory, right? So we don't need to know in detail of architecture. So we are, even I will not go in detail of architecture. Whatever I say is just like a basic components I'm explaining in Teradata. But once
Okay.
we go into the real-time classes, we'll be working on the queries, on the functions and Teradata BTEX scripts, all the real-time environment things, mostly on hands-on training. So that the architect is
Again, we
only
will
for,
have some triggers, cursors, everything here.
yeah, everything will be there, functions, macros, triggers in Teradata. Also we have all the things that is there in other databases as well. So we have a BTEC
Okay.
utility. BTEC is like a batch Teradata query where you can actually write multiple SQL statements, like a procedure kind of stuff that we do mainly in real-time environment with other ETL tools like Informatica or Ab initio or data stage. We do with other data tools the BTEC scripts. The BTEC scripts is nothing but a procedure kind of Teradata. You can execute multiple
Okay.
SQL statements within a single script. Okay. So we'll
Okay.
be talking about all the utilities and the Teradata scripting and the database development programming, right? Not about the theoretical part. So when we will be talking about one or two classes on the Teradata architecture and other basic stuff, and then we'll go with the main classes. Okay?
Okay, Raj.
Any other question, guys? You clear on parsing engine part? What actually Teradata
Yeah, Raj.
architecture is of? Yeah.
Yeah, AMP you said right. AMP will select data randomly, or it follows any specific rules to extract data or
Yeah,
top to
that's a good.
bottom or.
Right. That's a good question. While storing the data in Teradata, there is no proper order will be followed for any records. So it is like a random distribution in the AMPs, and whenever you read it from AMP based on the hashing value for the each corresponding ID in the database will be represented by the hash value. Okay? In Teradata, everything will be stored based on the hashing algorithm. So that is the biggest concept. Again, we are not going into the detail of it. Hashing algorithm is like a unique key. What is a alphanumeric key in computer language? If you talk about hash value, something a specific value for each row. So that what happens while you distributing the data will be stored across all the AMPs with the different hash values, not in any particular order. And when you're trying to retrieve the query, so based on some condition that you search it, it will only check for the corresponding value. Otherwise, it will take the entire table scan with respect to your table query. Select star from table name is the costliest query, right? Because we are selecting everything from the table. But in real time, we never do that select star from table name. We do only the limited columns and join with other tables. Correct? So in that case, it will check for the primary index, whether you have a primary index on the table, what is the condition in where clause that you given for your filtration criteria. So all these steps will be taken by your parsing engine, and it will suggest the best plan to get the data. So it is your duty as a developer to guide the parsing engine in a proper way, because it doesn't know until unless you, for example, there is a concept called statistics. So if you don't color the statistics on the table, parsing engine doesn't know how many rows are there in the table. For example, select star from table. Let's say you have 100 rows in that, and parsing engine should know that there are 100 rows in the table for getting the data. So this much is the spool space, and this is the maximum time for getting the data. These are all the details given by your parsing engine, right? So in that case, a parsing engine will only come to know when you have the stats defined on the table, so that it can know that, okay, well, there are 100 rows at this moment. Okay, I can give you the best plan based on this, right? So it is completely depends on the our development capability, how you're driving your parsing engine. Though it's a Teradata component, it's basically in your hands how you write your queries and how you drive your parsing engine. Okay.
How you will come to know that statistics are not defined on particular columns on table?
Yeah, you can actually, there are commands in Teradata, help stats. If you give help stats table name, it will just show you whether the stats are there or not on the table. That is what we check in the real time. We collect the stats every time. Stats are nothing but it will give you the unique row count. For example, if I collect the stats today, I have 100 rows, and tomorrow I have added again 50 rows to the table. So I refresh the stats again tomorrow as well. So that 150 row count is my unique row count of a table. That will be stored in some table called TVC. The table will be there. So that table will have all this information, that statistics information, so that whenever you write the query, parsing engine will go to the table and see, this table have the statistics already defined. So I have 150 rows today, so I can give you this much spool space and this much time estimated with high confidence, right?
So explain plan will use that statistic
Yes,
to get the data, right?
right.
Means,
Explain
how
plan will
much
get
time?
the, yeah, explain plan. If you see here in Teradata, explain plan will say that approximate rows are 7 rows with high confidence, right? So this high confidence, and there are sometimes no confidence and low confidence will be there based on your statistics. So if the parsing engine already knows that the stats are up to date, it will give you with high confidence, and spool 1 is estimated with 287 bytes. So it will assign some space to the spool 1. Spool is nothing but a temporary space whenever your query is writing actually, right? So that space can be allocated based on your estimation of the count, and it will be estimated with this much size and this much time for the row to be completed, right? This is just a rough estimate, okay? This might not be exact and accurate.
Okay.
And that is what, for example, here high confidence is basically because of the reason that we collected the stats recently on the table. Otherwise, parsing engine never knows that, there are 150 rows. It is still thinking that 100 rows only if you don't update the stats, right? So the entire calculation might go wrong, because it might say that, these are the 7 rows, 150 rows. Instead of 150, it will say 100 rows as of now with low confidence. So that matters. Basically, these simple things can matter your performance.
Okay.
Clear?
And we'll be having sessions on hashing indexing, or at least brief introduction.
Yeah, we cover all the index like primary, secondary, and NOPA, no primary index. So that is that will be covered as part of the course. So let me just go through the course content quickly. You got the overview of Teradata, right? This is just a brief introduction about Teradata. So now let me go to the course content, what actually we cover, right? This is like a 20-hour online training classes, daily 1 hour, okay? And so if you see the training index, we'll be covering the architecture, parsing engine. We cover like small things about parsing engine, AMP, Binet, and we'll go with the remaining topics like in Teradata components. All these are Teradata components only. We'll be talking about these initially, and then we'll be coming to the spool management or data protection, like how the data will be there, fallback mechanism, journaling concepts, types of logs in Teradata, and all these things in the space management and data protection. And coming to the data distribution, again you are asking, right, hashing algorithm, secondary index, unique primary, hash index, all these things will be covered in the Teradata data distribution, because based on these categories only the data will be distributed, like row hash, row ID, hashing algorithm, primary key versus secondary key, primary key versus primary index. So NOPA, data retrieval using USA and NUSA, unique secondary and non-unique secondary. We'll be covering all the indexes here in the data distribution, right? And then we'll be talking about explain plan here. other index and like join index, PPI. There are different indexes apart from primary and secondary, like partition primary, join index, hash index. Okay, and explain plan is very important. How to read explain plan, main keywords in detail of each and every word, and different indexes available in Teradata. Okay, so after that we'll be talking about strategies, join strategies, and the statistics. Color statistics is important. High, what is high, low, and no confidence. Teradata performance tuning with respect to this, and all your joins, inner, outer, left, outer join, cross join, forward join. Okay, we'll be talking about the join strategies here. And then Teradata SQL also will be talking about data types, functions, string functions, format, analytical functions, cached functions, and qualifier, row number, rank. All this SQL will be covered as part of Teradata SQL. Okay. After that, we'll be talking about the important concept of utilities. Teradata came up with a concept called utility. So they have developed their inbuilt utility like BTEC, batch Teradata query, mload, fload. There are different scripts are available within Teradata to have for some specific purpose. For example, if you want to load some data into table, they have some fast load, something like that. Okay. And once we cover the utilities, we'll be talking about best practices, how to do the standardized coding, and what is the development best practices, and installation as well. Installation in the sense will be providing you the software with Teradata to practice on hands-on. Like you will get a server like this VMware. This is a Teradata server, whatever I'm just showing here. This is a VMware. This is a Linux server. Okay. So you'll be getting this Linux server Teradata and then SQL Assistant to connect to your database and write your queries and all the stuff here. And this server will have the Teradata scripts like BTEC and all. We can run all the scripts in the server. Teradata SQL Assistant is only to run the queries, not any scripting here. We cannot actually do that. We can actually only run the queries here, and we can actually do the remaining stuff on the Teradata server, the VMware that is installed here. Clear? Any questions here on this content and syllabus? Yes.
Again, that Teradata SQL Assistant we will be installing on VMware or our local?
No, it's on the local machine. VMware is only for the server, the VMware server. I mean the Linux server. SQL Assistant will be on your local desktop. So for that,
so again we will give the
right.
Okay, good. Sorry.
For that you actually need. Yeah, I can give you this version, downloaded version to you. You can actually directly download and you can install it.
Yeah, I have tried to install it. It is asking for DNS names from my local system while executing something. I mean.
Yeah, maybe I can help you with that, not a problem. So once we install the server, you can actually install the client and we can actually connect both the client and server. Even it's in remote server, we can still connect. Like here, this is the server I have, and I have Teradata SQL on my local desktop. This is my local desktop. This is my VMware. So still I can connect to this by way of mechanism is there. I can tell you definitely not a problem. Once you register for this, we'll be providing you the software and installation advice to you. And there's a recording already for the installation. You can actually go through it. It is very simple. Only thing is you have to give proper things while downloading and the stuff, but it is a simple thing only. Okay. And one more thing is, for installation of Teradata, you should have at least i3 or i5 or i7 processors. Okay. I think I hope already you have all the latest processor with you. Minimum i5 is okay, because the VMware won't support the virtualization otherwise. Okay. And Windows 7, Windows 8, anything is fine.
Okay.
You'll be teaching them how difference between the version to version. What is the latest version?
Yeah, that is the primary thing that we do. I mean, See, ideally in Teradata perspective, we don't have much difference between the version because architecture is pretty same. We have some improvements in the performance of a queries or some fixes. So if you actually take info.teradata.com website, right, if you take a version to version, it will clearly list out all the differences with respect to some new enhancement on the functions and something like that. Architecture wise, there is pretty much same, okay, but we'll be talking about the difference.
Okay.
And you have basic SQL knowledge with you, or how good you are at SQL, guys?
I'm good at SQL.
Teradata, there some functions are in Teradata. Some functions are there which are not in Oracle, I guess.
Right, functions will be covering the SQL. I'm talking about the basic joins and these stuff, insert, select, create, these things. Anyways, we'll be covering that as part of our course. I'm just asking like how good you are at SQL, because everything is about SQL, right? Teradata is completely on the SQL only. So the functions and SQLs and macros as well, and BTech is finally the thing based on these factors. And 70% of the real-time work will be done in BTechs only. Okay.
Okay.
And TPT is a new connection that is comes in Teradata right now. TPT is like Teradata Parallel Transporter. So that is actually replacing all the existing utilities, it seems, except BTech, like fast load, mload, fast export. So those are the old utilities, and Teradata comes up with TPT, the new utility. Basically, it will have all these enhancement with the fast load, mload, and fast export. All these utilities will be singly, clubbed into a single thing called TPT now. And Teradata is really good in the market right now because most of the biggest IT giants are using this because of the data warehouse size and all the complexities, and especially in healthcare and investment banking domain. Okay, just for your information. Only bigger companies can afford Teradata because it's a costlier one. So any other questions before we wrap up on the course content or software or the, we're good?
I hope so much.
Okay, no problem. I'll send this material to you, the course content. So I can ask BigClasses team to get back to you. Please respond to them as early as possible in case they call you on your mobile, okay? So that we can actually commence the classes soon. Alright, hope to see you soon. We'll meet again. Bye bye.